Hello everyone, we have been asked to find all the feasible solutions of this equation within a range of 0 to 2 pi. So in the first instance, if we look at the equation, we can see that there is a common term between the two terms of the equation, which is 81 to the power of sine squared of x. So let's rewrite this equation to see if we can simplify it. So we'll keep the first term as 81 raised to the power of sine squared of x, and let's decompose the second term. So we have 81 to the power of 1 minus sine squared, so it is going to be 81 times 81 to the power of minus sine squared of x equal to 30. So we know that any number to the power of a negative term can be rewritten as, so for instance, a to the power of minus 1 is going to be rewritten as 1 over a. So basically it reverses the numerator and denominator. So we can rewrite this equation as 81 to the power of sine squared of x plus 81 over 81 to the power of sine squared of x equal to 30. Then let's do a change of variable in order for us to simplify the equation. So if we consider that f of x, or let's say y, is equal to 81 to the power of sine squared of x, and rewrite our expression in terms of variable y, we will have y plus 81 over y equal to 30. We know that y cannot be 0 because any number, any real number raised to any other number will any non-zero number raised to the power of any value cannot be 0. So we are allowed to multiply both sides of this equation by y. So if we multiply both sides by y, we will have y squared plus 30y, and we take it to the other side, minus 30y plus 81 equals to 0. So we ended up with a quadratic equation, and let's see if we can find the roots of this equation. So one way is to basically factorize this equation. So we will have y times, so these two numbers here the sum of these two numbers here should be minus 30, and their multiplication should be 81. So we will have 3 and 27 both negative equal to 0. Then either y can be 3 or y can be 27. So let's go back to our change of variable. We had y equal to 81 to the power of sine squared of x. So if we assume that y is 3, then and rewrite this in terms of powers of 3, so we will have 3 to the power of 4 times sine squared of x, which is gonna be 3. Then from here, we can see that 3 is, we can rewrite 3 as 3 to the power of 1. Then we'll have sine squared of x equal to 1 over 4, and from here sine of x is plus minus 1 over 2. So we need to find all the solutions of x that they will have plus minus 1 over 2 within 0 and 2 pi. If we just use the unit circle, so this is sine of x and this is cosine of x. So let's say this is sine of x plus and minus 2. So there are 4 solutions for this. One is here, this alpha, and also one solution which is this one, for 4 solutions. So but the general solution of this equation is x equal to k pi plus and minus, so only 30 the sine of 30 degrees, or pi over 6, is 1.5. So we will have k pi plus minus over p over 6. So in the range of 0 to 2 pi we will have 4 solutions, which is if we put k as 0, we'll have pi over 6. At k equal to 1, we'll have pi plus pi over 6 and pi minus pi over 6. And if we have if we put k as 2, then the only value that will be within 0 and 2 pi will be 2 pi minus pi over 6. So these are 4 of the solutions when we have y equal to 3. Let's now try y equal to 27, which is 3 to the power of 3. Then if we plug the equivalent of y in our change of variable, we'll have 3 to the power of 4 sine squared of x. Then from here sine squared of x is 3 over 4, and sine of x will be plus and minus square root of 3 over 2, which means x, if we so on the unit circle, x will have the form of x is equal to k pi plus minus pi over 3, or 60 degrees. So within 0 to 2 pi range we will have pi over 3 for k0, and if we put k1 we'll have pi plus pi over 3 and pi minus pi over 3, and if we put in k as 2 pi, we will have 2 pi minus pi over 3 as a solution. So within the range of 2 pi, 0 to 2 pi, we will have 2 sets of solution, each with 4 solution, and which results in totally 8 solutions within 0 to 2 pi. Thank you very much.